this sequence, 7, 16, 25, 34, etc., ending in 574, we're being asked to find how many terms there are. We know that the first term is A1. We can determine by looking at this that the difference is equal to 9. We do know that this is arithmetic, and we do know that this is going to be the nth term, but we want to know what exactly n is. How many terms out have we gone to get to that 574? So we will use this nth term formula yet again. Write it down. Every time you write it down, you're going to memorize it all the better. We do know that 574 is going to be found when you start with 7, the first term, and you move forward 9 n minus 1 times. When you subtract the 7 off of each side, you will then have 567 is equal to n minus 1 times 9. Now, you might feel the urge to do some distribution, but it's a lot easier just to divide the 9 off of each side to get 63, and then add 1 to each side to find out that there are 64 terms in this sequence. Okay, now we begin a little bit more challenging of a problem. We are given a sub 5 and a sub 11. Here's the first term, which is unknown and which we're trying to find, a sub 1. The second, the third, the fourth. The fifth term will be 47. So that'll be a sub 5, a sub 6, 7, 8, 9, 10, and then a sub 11 will be 113. Now you could play the guessing game and say, okay, let's start adding something like 5. Add 5 all the way through, try and find it. Try adding 10, try adding 15, and play the high-low game and see if you've got the right value of D. But there's no guarantee that these are going to work out nicely. What if you're supposed to be adding something like 4 1/7 to go from term to term to term? That's where you need to have a strategy. And the strategy we're going to use is we're going to relabel the subscripts. Rip off the beginning here. Pretend this a sub 5 is now a sub 1. And a sub 11 is now going to be a sub 7. Notice how I've subtracted 4 from the 5 to get to the 1. We're going to subtract 4 from the 11 to get to the 7. Now we will use this notation here to find the value of D. Let's use our AN formula, A1 plus n minus 1D. And we will write 113 is what we get when we start with 47 and we move forward a value D, yet unknown, 7 minus 1 times. So, subtracting the 47 on each side, we get 66 equals 6D, and therefore D equals 11. In this case, we could actually backtrack to term 1 very easily by subtracting 11 and just doing that manually. But we're 4 terms away. If this were a greater distance between the two, that might not be very practical. So what we're going to do here is we're going to return to the original subscripts. And we're going to use the formula again. A sub n equals a1 plus n minus 1d. Now you have a choice on what you want to be your nth term. Do you want to use 47 as the 5th term or 113 as the 11th term? I think it's a lot easier to use the 47 because that number is smaller. So we are going to say the following. 47 is going to equal the first term plus 5 minus 1 times d, which is 11. Since 47 was the 5th term, we substituted in n equals 5. This gives us 47 equals a1 plus 4 times 11. That's 44. If we subtract that 44 on each side, we will find out that the first term, a sub 1, is equal to 3.